is let's see how we do. So you can shout out answers when I ask for them, or you can just mark yourself and see how you do. Okay. All right. So what's an amplitude? Yep. No, it's not B. It's not B. Sorry. Yeah. Half of B. Oh, B over 2 is amplitude. Can half a B still be a B? Or is half a B not a B? All right. I think there's a song about that called Eric the Half a B. You can look that up yourself. So half a B would look like this. And if you're only half a B, are you still a B? Is the philosophical question. All right. And it's one of those to be or not to be. Anyway. All right. So what's a wavelength? Yeah? What is it? A? Yes. It is. A is the first and easiest answer. If you're going to use multipliers, what could some other A value, or sorry, what could some other wavelength values be? Yeah? 2C. All right, somebody else. What's another one? 2E. Yeah, look at that. You see how E is from a peak to a trough? So 2 of that would be a whole wavelength? Yeah, 2E as well. So some people are working ahead now. They're like, oh, I see how this works. All right, so a quarter wavelength. Oh, not a quarter, a half wavelength. What's a half wavelength? C and E, yeah. Is there another one? Half of A, yeah. What about quarter wavelength? Could we just take the previous line and divide them all by 2? Yeah. C over 2, E over 2, and A over 4. All right, so people say, well, why would I care about half wavelengths and quarter wavelengths? It turns out that later on, when we talk about resonance and things, we need to know about quarter wavelengths and half wavelengths. Okay, so usually when people write those things, a half wavelength, they'll even write this as lambda over 2, and a quarter wavelength, they'll just write it as lambda over 4. And of course, a wavelength is just lambda, and amplitude is A for amplitude. Okay, that's how half a B can be an A. Yeah. All right. Terms that I want to make sure that people know. We're going to go on to some more stuff, but make sure, and these are the terms that we've talked about so far in the lesson. We've talked about what amplitude is and recapped it in this quick little quiz. We've talked about what wavelength is. We've talked about what a peak is, or a crest. We've talked about a trough. We talked about what a pulse is, transverse. We also talked about longitudinal. And within longitudinal, we talked about compressions and rarefactions. So, I mean, what a vocabulary wonderland, right? Like, there's a lot of stuff going on here. And we should know what all these terms mean if you are able to reflect back on the note up above. I would suggest that if you're one of those people that's like a flashcard person or likes to use like, I don't know, AI for studying or something, work on making sure that you know all your vocab because you should be really fluid about it, okay? So I've said that a couple times during the lesson, but being fluid with new vocabulary is helpful because it means that the ideas don't just kind of wash over you as somebody uses words you don't understand, right? Like that's terrible. What a terrible feeling. All right, so let's take a look at the next page. What I want to do is do some calculations. We got to do some math for this, of course. Before we get into the math of things, I want to define something. Period. And I don't have a nice space on the page for this, so I'm going to go right up in the upper margin, which I don't like to do a whole lot. But period is the amount of time for one complete cycle? So what's the period for a year? 365 days. Like that's one complete cycle. Doesn't matter if it's a wave or an orbiting body. A period is a period, a repetition cycle. Okay. Now, of course, there's math for this. What we say is, hey, if I wanted to know how long, what the period is for, like, let's say I took a yo-yo. You take a yo-yo and you undo the string. If I spun a yo-yo above my head and I said, what's the period for this yo-yo spinning above my head? Wouldn't I spin the yo-yo around like a whole bunch of times? And what you would do is you would time how long I was spinning the yo-yo for. And then you would divide by, maybe one of you was timing how long I was spinning the yo-yo for, and another person maybe was counting how many times the yo-yo spun around above my head. And so that would be an integer number, right? And so if I wanted to know the period for one yo-yo orbit above my head, you guys are picturing what I'm talking about, right? But here I am. Here's me with the yo-yo spinning around my head, right? If I could spin that yo-yo and you could count my yo-yo spins and time how long it took, I could calculate the period for a yo-yo orbit. Cool? That's period. So if we were going to label this up, delta T is time observed, and N is number of repetitions. Or cycles. Okay? And capital T is period. So this is case sensitive. Those of you that are really not good about being case sensitive with your variables, it matters. Okay? Of course, we've already dealt with that with temperature. Temperature has to be capital T, and then we have delta T for time as well. But period is another capital T. Annoying. All right, so a fly flaps its wings 150 times per second. And the question is, find the period of one wing flap. All right, well, so the number of times that fly flaps its wings is 150. We counted it. Notice that counting something doesn't have units. You just counted it. That's how many times it happens. It's not a unit measurement. It's just a count. Like you don't say, I have 150 eggs in my fridge. That would be a lot of eggs in my fridge. But if I had 150 eggs in my fridge, the egg would be the thing I counted. It's not a unit, right? In this case, we counted flaps. The amount of time, well, that's an interesting question. It says that it is 150 flaps per second. Doesn't that mean that it's per 1 second? So the delta T must have been 1 second. So if I was going to calculate the period, we just said that period is delta T over N. All right, 1 second divided by 150. Somebody with a calculator, help me out. What's 1 divided by 150? It's not going to be a big number.
Tiny.
Yeah. All right, 0.00, and then the 6 is repeated? All right, so that's how long it takes for one fly flap. All right, that's the period for a fly flap. Now somebody comes along and says, well, what's the frequency for a fly flap? That sounds like a tongue twister. The frequency for a fly flap is equal to, now this is something that we should really write another definition for. Frequency is defined as the number of repetitions that occurs in an interval of time. And if you look at that, you're like, oh, so frequency is just the reciprocal of period? Yeah, it is. They're just inverses of each other. So we could say, all right, well, that means that frequency is just 1 over the period. 100%. So I say, all right, well, then the frequency is equal to the number of flaps was 150. And 150 divided by 1 second. Now, the math on this is easy. But the units upset me. Can you guys see that that's 150 over seconds? That unsettles me. And so there's this guy that he was really into quantum physics and electron excitation. His name was Heinrich Hertz. You guys ever heard of Heinrich Hertz? Maybe not. Maybe you didn't know his name was Heinrich. I just think it's fun. It's a fun name. But Hertz, you've heard of a Hertz, right? So it turns out that 1/seconds is such an annoying unit that 1/seconds is equal to 1 Hertz, named after Heinrich Hertz because of his involvement with the way that frequency applies to quantum physics. Okay, so we're not going to go down that rabbit hole as to what he did with his life. You can look that up if you want to. I won't call him Heine because we're not friends, but Heinrich. Okay, but it's 150 Hertz, and nobody writes it as 150 over 1/seconds. They say Hertz. So I want to take a look at this watch with this new information. I want to talk about the frequency of a rotation of a second hand on an analog clock on this watch. So if I want to know the frequency, I have to know how many times the second hand's going around. Let's just choose that it's going around once. We could choose twice, but that's going to change the time, right? If it goes around one time, I know that's going to take 60 seconds. We can say 60.0 seconds if that feels better. By the way, integer numbers, integer counts, do not impact significant figures. Okay? So if I have an integer count of 1 or 2 or 72, that doesn't impact the number of significant figures because that thing either happened or it didn't. There's no margin of error on that. It happened or it didn't. All right, so if I want to calculate the frequency for the second hand going around, it's n over delta t, and I sub in my values, and I say 1 divided by 60 seconds, and I do my math, and somebody's going to help me out. 1 divided by 60 is, it's a small number.
0.016.
And is it the 1/6 that's repeated or just the 6? Just the 6. All right. What about the units? What's the frequency? Hertz. Nobody writes it as 1/seconds. So it is cycles per second. Look, it's a fraction of a cycle per second because it takes a whole minute to go around, right? But everybody writes it as Hertz. Cool? All right, so I used to take my kids to the park a lot and push them on the swings. And as I'm pushing them on the swings, they're older now, old as you guys, almost. I watched them go 5 complete cycles. And as I timed them going 5 complete cycles. Took them 8 seconds. I didn't have my stopwatch out. I just said 1 steamboat, 2 steamboat, 3 steamboat, so on, right? Now, if I'm writing this out, I'd say, all right, well, my n value is what? You guys tell me. Come on. 5. Answer 5, yeah. Delta t, 8 seconds. What's the period for a swing? Oh, no problem. Period. Delta t over n. 8 seconds. 5 swings.
1.6.
What is it? 1.6. Nice. No repeaters this time. 1.60 seconds. Beautiful. 1.60 seconds for a swing. Hey, if they were to swing, I don't know, 10 times, how many seconds would it take? 16. If they were going to swing 100 times, how long am I going to be at the park for? 160 seconds, right? You see why it's useful to know the period? Because since it's repetitious, now that I know what the period is, if I want to time how long it takes for multiple cycles, I can just multiply it. It's just a multiplier, right? Yeah.
What's the variable for period? Is it t?
Capital T for period. Yep. So it's case sensitive. Lowercase t for the time that goes by, capital T for period. What's the frequency for this swing? You guys, some of you have already beaten me to this. N is over delta t. Sub in my values. I get 5/8 seconds. get an answer. Other people maybe did it this way. They just said, oh, well, we already calculated the period, so why don't we just do that? 1 divided by 1.60 seconds. What do you suppose is going to happen here, depending on what kind of thinker you are? Same, right? Going to be the same answer. You guys tell me, is it 0.625?
Yeah.
Yep. 0.625 hertz. And so regardless of which way you process this information, you get down to the same answer. And that's good. It's nice to have divergent thinking come towards the same answer in the end.